bones. Okay, we finished talking about cartilage and we talk about bone. Bone is very hard. They're connective tissue. Okay, bone, they are living tissue. They are not dead. They are hard, but doesn't mean that they are hard and rigid, but they allow small degree of bending. They have calcium salt. They also have collagen fiber. Calcium salt and collagen fiber together make the bone very rigid, but they also have protein fiber that give the bone relative some kind of elasticity and strength. So bone is not like steel. Okay, steel there's not much of the flexibility, not much of the elasticity. Bone, it has elasticity. It's not completely rigid. There are two types of bone: compact bone and spongy bone. Compact bone, they form the shaft of the bone. They have something called osteon. In the center of the osteon, we have something called central canal. Central canal is surrounded by a matrix, and then it's like the tree ring. It literally looks like a tree ring. And then we call the entire tree ring is called osteon. They are formed by osteocyte. Osteocyte, they are the bone cell. The osteocyte, the bone cell, they also bathe themselves in a jacuzzi called lacunae. So you can find the osteocyte in this lacunae, the lacuna. The spongy bone, they are the bone that have very small, many bony bars, very small irregular spaces. They usually find at the end of the long bone. They are designed for strength. They're designed for strength. They are lighter because they have a lot of empty space in it. They have a lot of empty space. And because spongy bone, because they look literally like sponge. It has a lot of empty space. The empty space is not really empty. There are a lot of blood vessels going through this empty space. They are highly vascularized. They are at the end of the bone. So you can see that, okay, compact bone, okay, this is the osteon that I talked about. It looks like a tree ring, literally. This is the central canal, and you can see that osteocyte, this is the osteocyte, it's inside one lacuna. The dark spot here, this dark spot here is one osteocyte living in one lacuna. You cannot tell the differences. You can only see a dark spot here, dark spot here. Basically, it is one osteocyte living in one lacuna. Canalically, they are basically a tiny little canal that connects the lacunae together, multiple lacunae together. They connect multiple lacunae together. You can see that, okay, this is the compact bone and this is the spongy bone that I talked about. You see the spongy bone? They have a lot of hole. It looks literally like a sponge. Blood vessels go through them. And the compact bone, they are on the side of the shaft. They are rigid. And then you have blood. Blood is considered as a connective tissue. The reason is that they have cell and matrix. The cell, they are the blood cell, red blood cell, white blood cell, and platelet. So all these are the cells. What about the matrix of the blood? The matrix of the blood is the plasma, blood plasma. So, however, plasma is not made by the blood cell. Plasma, they are mostly water, consists of water. And then the function of the blood transport nutrient, namely glucose and amino acid, and then oxygen, and remove carbon dioxide and metabolic waste. They help to distribute heat. Play a role in fluid, ion, and pH balance. pH balance is important. In the blood, we use bicarbonate ion to maintain the pH level. Play a role in fluid balance. Fluid balance, when we talk about the urinary system, you learn more about this. Protect against disease because we have white blood cell and the immune system. And the blood clotting factor. Blood clotting, we have a platelet cell. We have a fibrin or fibrinogen. So those are the proteins that can crisscross to form a network to stop you from bleeding. Component of the blood, we call it hematocrit. Hematocrit. Approximately 55% of the blood, they are plasma. Approximately 55% of the blood is a plasma. Plasma contains inorganic or organic substances dissolved in water. Plasma is mostly water. And the 45% they are so-called form element. What are the form elements? For example, you have a red blood cell. Red blood cell, you have to call it erythrocyte from now on. Erythro meaning red, and this side means cell. White blood cell, leukocyte. Leuko means white, and then you have this side cell. Platelet, thrombocyte. Because this cell, they have a chemical cascade. They are activated by thrombosing, some kind of enzyme and some kind of blood clotting factor and enzymes. So plasma, what do you have? Plasma, majority of plasma, they are made up of water, and then approximately 10% of it, they are the solute. Like inorganic ion, we call it electrolyte. Remember, electrolyte, they're basically just salt, sodium, potassium, calcium, so on and so forth. Bicarbonate ion is important because it helps to maintain the pH level of our blood. Gas, mainly oxygen gas and carbon dioxide gas. Plasma protein, what are the plasma protein we have? We have albumin, globulin, fibrinogen, transport protein, and they also have antibody. Antibody is considered as a plasma protein as well. Globulin, immunoglobulin is a form of antibody. You also have globulin as a carrier protein to carry hormones. Fibrinogen, I briefly mentioned it. It is an inactive form of a protein. The active form of the protein is called fibrin. So when fibrinogen becomes fibrin, what happens is that when fibrinogen becomes fibrin, then fibrin will start to crisscross to form a network of a protein fiber. And then you will help to stop, you will trap the red blood cell to stop the red blood cell from leaving of the opening of your wound. Your blood also contains metabolic waste, urea, ammonia, and uric acid. And then we have regulatory substances like hormones. And enzyme. Hormone, you can have protein hormones, you can have steroid hormones. Enzyme, they are also protein. Enzyme, it can be a digestive enzyme, and so on and so forth.